As we approach the winter months, weather patterns in the northern hemisphere start to shift. Cold air out of the Arctic plows down into the United States and brings with it colder temperatures. But what happens when these air masses meet up with moisture, especially from the Atlantic Ocean? Let's explore the meteorology behind nor'easters. In the months of December, January, February, and March, mid-latitude cyclones make their trek across North America, Europe, and Asia. A mid-latitude cyclone has similar circulation to a tropical cyclone, except it's connected to fronts, with the two main ones being a warm front and a cold front. In the context of mid-latitude cyclones, the cyclone center, the low-pressure system, is typically associated with the convergence of air masses, which can include both warm and cold air masses. Therefore, you would often find warm and cold fronts extending outward from the cyclone center. The interaction of these fronts with the cyclone circulation leads to the dynamic and often stormy weather associated with a mid-latitude cyclone. Depending on the location of the storm, some places may be on the warm side of the storm, while others may be on the cold side. When these storms occur with warmer overall conditions, generally everyone will see rain. With colder conditions, it's a different story. The southern and eastern side of the storm is the warm side, while the northern and western side is the cold side. If the temperature gradients are pronounced, the warm side will likely see rain, and the cold side will likely see snow. In between, some areas may see mixed precipitation, such as sleet and freezing rain, which is one of the worst forms of precipitation in the winter. Heading to the eastern seaboard of the U.S., mid-latitude cyclones become more complex with the introduction of the Atlantic Ocean. Here, they get a boost from the warmer ocean and become stronger. The name of them is what we call nor'easters, which get their name from the strong northeasterly winds that are often associated with these powerful storms as they affect the northeastern United States. These storms will be the focus of this week's episode. First, we'll explain what nor'easters are and the conditions they create for the areas they frequent the most. Then, we'll mention some of the most notable nor'easters and why they are regarded as that. Then finally, we'll examine if climate change is making nor'easters more vigorous and frequent. Before we begin, if you enjoy learning about geography and earth science, be sure to subscribe to my channel, Our World, Our Planet, Our Home. Let's get started. As mentioned before, nor'easters are mid-latitude cyclones, except they're stronger and more dynamic. They develop as low-pressure systems that move northward along the Atlantic coastline. Nor'easters are most common during the fall, winter, and early spring, with the peak month regarded as being February. They thrive on the temperature contrast between cold air masses from the north and warm, moist air from the Atlantic Ocean. Within the Atlantic Ocean, the Gulf Stream, a warm current originating in the Caribbean Sea and Gulf of Mexico, keeps ocean waters warm off the coast of the southeastern United States. When a track allows a nor'easter to develop there, the warm current gives extra fuel to the storm. From there, they make their way up the east coast into the mid-Atlantic, Northeast, New England, and eastern Canada. Nor'easters can bring a variety of precipitation types, including heavy snowfall, rain, sleet, and freezing rain. The type of precipitation depends on the factors such as the storm's track, temperature, and location. For example, if a nor'easter tracks too far east, places such as New England may see the brunt of the storm, while westerly locations such as New York City, New Jersey, and the Mid-Atlantic states may see minimal impacts. If the storm tracks far west, all areas in the immediate eastern seaboard will be warmer, generating heavy rain and winds, while areas within the interior and northeast, such as Pennsylvania and upstate New York, may see heavy snow and blizzard conditions. One locational area meteorologists go by is the 40-70 benchmark, which is when a nor'easter tracks in a direction that brings the center of the storm over 40 degrees north latitude and 70 degrees west longitude. This will usually bring snowy and windy conditions to all locations from the mid-Atlantic to New England. Since many nor'easters have lots of available moisture, they can dump a lot of snow. Many cities such as Boston, New York City, and Philadelphia all have the highest one-day snowfall records of higher than 20 inches. Some surrounding areas of these cities can get between 3 to 4 feet of snow with some storms. Right along the shoreline, winds from these storms can be intense, with some locations such as the Jersey Shore, Long Island, Nantucket, Martha's Vineyard, and Cape Cod getting hurricane-force winds. Strong winds plus storm surge from the ocean can create damages, including coastal flooding, beach erosion, and power outages. In the last century or two, there have been many notable nor'easters, not only known for their intensities, but also known for being bust, meaning they never materialized to what was forecasted. Let's start with the intense ones. The Great Blizzard of 1888 was an historic nor'easter which struck the eastern United States in March of 1888. Because of the time period, there was no forecast modeling, and the storm came as a surprise. It brought heavy snowfall, strong winds, drifting snow, and record low temperatures, paralyzing major cities like New York and Boston. The storm resulted in significant transportation disruptions and numerous fatalities. 103 years later, the perfect storm occurred in October of 1991. Made famous by the book and movie of the same name, this powerful nor'easter was a result of the convergence of a hurricane and a cold front. It affected the northeastern United States and Canadian maritime provinces, causing massive waves, coastal erosion, and significant damage to boats and infrastructure. In the 2009-2010 winter season, several powerful nor'easters struck the northeast and mid-Atlantic. The first major one was in late December 2009 when a powerful nor'easter trekked over the mid-Atlantic states, dumping copious amounts of snow on Long Island, South Jersey, Delaware, Maryland, Virginia, and Washington, D.C. In January 2010, there was a lull, but activity picked up in February. An extremely powerful nor'easter pummeled the Mid-Atlantic region from February 5th to 6th, dumping 2 to 4 feet of snow in Delaware, South Jersey, Maryland, Washington, D.C., and Virginia. 4 days later, another powerful nor'easter dropped 2 to 3 feet of snow north of the previously impacted areas, now including much of central and northern Pennsylvania and New Jersey and New York. Then, in late February, another very powerful nor'easter affected areas in northern New Jersey, upstate New York, and New England, with 2 to 4 feet of snow. In the 2009-2010 winter season alone, Washington, D.C. recorded 56.1 inches of snow, the highest ever recorded. Not all nor'easters materialized as they were supposed to, as was the case with the late January 2015 nor'easter. Initially, forecasters predicted that the New York metropolitan area would get anywhere between 2 to 3 feet of snow and issued a blizzard warning for the entire region. However, the storm moved further east than anticipated, and New York City only got between 8 to 10 inches of snow, and areas of northeastern New Jersey received only 3 to 6 inches. But since the storm center moved east, New England received the bulk, with parts of Massachusetts receiving 3 feet. Meteorologists usually get blamed for forecasting errors. However, it's not their fault, as nor'easters tend to be very unpredictable storms. In a changing world, climate change, both naturally and artificially induced, may be contributing to dynamics associated with nor'easters. One concern is the warming oceans. Over the course of several decades, there has been evidence that sea surface temperatures are warming gradually. Warmer sea surface temperatures in the Atlantic Ocean can provide more energy for nor'easters, potentially leading to stronger storms with higher wind speeds and heavier precipitation. With added moisture plus available cold air, snow accumulations can become higher. In the winter of 2014 and 15, Boston received over 110 inches of snow, a record for the city. Whether this was associated with climate change is unknown, but it's possible. Climate change can also alter the typical tracks of nor'easters. There is evidence to suggest that nor'easters may move further northward or eastward in response to changing atmospheric and oceanic conditions. This could impact which areas are most frequently affected by these storms. Timing is also something that could be altered with climate change. On October 29, 2011, an early season nor'easter impacted the Northeast, including Pennsylvania, New Jersey, New York, and New England. October 2011 was seeing above average temperatures, but late in the month, a strong cold air mass moved into the area, coupled with the developing low pressure system. This combination created an intense snowfall for the region. In addition, many trees still had their leaves on them, and heavy snow caused many fallen trees and branches, creating many power outages. The unusual timing of the storm and erratic temperature shifts may be linked to climate change. One thing is certain, and this is that nor'easters will continually impact the northeast United States and eastern Canada. The region's unique geography allows this to happen. Will more noteworthy nor'easters occur in the future? It is likely, however, the directly correlated to climate change is questionable. It's possible, but more data has to be analyzed to connect the dots. What do you think? If you'd like to leave your feedback, please do so in the comment section below. Thanks once again for watching this week's episode. Remember to subscribe to my channel, Our World, Our Planet, Our Home, to learn more about geography and earth science. Until next time!